In this lesson, we're going to learn how to do weblog analysis with Apache Pig and Azure HD Insight. First, let's talk about what is Pig. And Pig is a tool that is most closely associated with Hadoop. And it's really a container for a language called Pig Latin, which is a high-level language, and it's designed for analyzing large data sets. This language actually came about as a result of the need to do analysis within big data environments like Hadoop, but using higher level tools, not Java, but more scripts and things that could be used by analysts, not so much by programmers. Pig is built from the ground up for parallel operation, which makes it ideal to be used in a distributed environment like Hadoop data nodes. It's particularly well suited for data parsing and transformation, which is what we'll do with our weblogs. And as we'll also do with our weblogs, we'll see how Pig is very good at multi-step transformations in a very concise and easy ways. And if you're thinking this sounds a lot like an ETL tool like integration services, you're probably thinking along the right direction. Pig is really well suited for ETL kinds of problems. And Pig was really designed for Hadoop, and it's tightly integrated with the Hadoop infrastructure. So as we run our Pig scripts to do data transformations, they will actually spawn MapReduce jobs through the Java streaming infrastructure. So let's take a quick look at what our source data looks like, and this is what it is. This is a log from Internet Information Services version 8, which is a Microsoft Windows-based web server. If you've used weblogs before, this looks pretty familiar. At the top of each log file is some header information that we really don't care about in terms of analyzing hits and whatnot. So part of the Pig script will exclude any line that begins with a pound sign that you can see there. There are a bunch of those. The meat of the Pig script will read each line from the log, parse it apart into its component parts, and then we're going to actually just do some counting of how many hits by site within all of the logs that we have. Our script looks like this, and this is the entire script. So you really notice it's very concise. In fact, most of the lines in the script are just a definition of what columns are to be expected in each of the logs. The meat of the processing is actually only 5 lines of Pig Latin code. So the first line, no comments, equals, and it just says go and grab all the lines from whatever file I'm processing and pull out anything that doesn't begin with that pound sign. The next line uses a regular expression to extract out the site component of each line. The next line after that takes that list of sites and groups that by the first column, which is just the site name. The next line just adds up how many hits are there by site. And then the last line is taking that final result set and storing that into the output in a tab delimited way. So if you think about what this is doing, it's an ETL job. It's taking a bunch of input files, it's parsing them out, and summarizing them into an output file. In order to run this script, we'll actually run the second command, but I do have one command above that, which is to delete the output. It's just some housekeeping. So as part of the batch routine that I'm going to run, I will just delete this count hits folder if it exists. And take special notice that we are running on the HD Insight for Azure environment, so we're storing and fetching our data from the Azure Storage Vault or the blob storage. And the format of a blob storage string is like this. It starts with ASV : whack whack, and then the BGHDI storage is our storage account. The .blobcorewindows.net is kind of standard, so I left that in red. Weblogs is our container name, and then at the very end is the path below the container. So that's what the Hadoop fs command will do, is just delete that folder. The next command is actually running the Pig script itself. So it's calling the Pig command file out of this snapshot bin folder. The first parameter is the name of the script. So file hitsbysite.pig, and that script is what we just went through on the previous slide. The next parameter is the input folder, where all the log files will be stored. And then the final parameter is the output, where the output will be stored. Before we run the script, let's just look in our blob store and see what we have out here. And so here I have my storage account, a number of containers within that, and one of those is this weblogs folder. So our input from weblogs will be these files, and these are just a lot of weblogs that have been dumped into the folder. The pig script will be run in a distributed way, so it'll probably run on each node within the Hadoop cluster. Each instance of a script running on a node in the cluster will be given a file to process. And if we look at these files, we can see they look just like what we had on the slide. The output, when it's generated, will be landed in this folder where we can fetch it or look at it or put a Hive table over it or whatever we want to do. So let's go ahead and run these commands. What I've done is taken the commands and put them into just a simple Windows command file so that I can run them in a script, and maybe I could schedule this within the Hadoop infrastructure if I wanted to. So to run that, I'll start the Hadoop command line. And in the projects folder here, I have my batch file that I just showed you. The pig script is located in the same folder, and I'll just run that. And if you watch carefully, you can actually see that the Java MapReduce infrastructure is being called up to go ahead and run what this pig script is trying to do. And when it's all done, we'll just get a success message. And so the pig script is done. We have a success at the end. So let's go and look at our output and see what we have. So now in our output, we have a folder called count hits. If I drill into that, I can see my part file. And then I'll go ahead and look at that in my favorite text editor here. And now what I have are a list of all of the sites that were found in all of the log files and the number of aggregate hits. So these hits would be spread all over the files, but what the MapReduce infrastructure has done is gone and read all the files in a distributed way, and then the reduce has pulled back together the counts. Very similar to the Twitter hashtag counting that we did in previous lessons.